Central tendency. One of the most important part, one of the most structural part of any statistical study. Why? If a student's average marks is 62 and another student's average marks is 59, the first one is better. If a player's average is 7 and another player's average is 49, the second one is better. So we always want to find the average, and the average is always a central value. So if the values are like this, 1, 2, 3, 4, dot 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 1 and 2, what is the average? The average is 50.5, the most middlemost value. How? Like 1, 2, 3, 4, the average is 2.5. So in the same way, it is 50.5. So your target is to get an idea about any format just by going to the exact middlemost point of the data, with the given condition that the data is expressed in ascending or descending order. That is very important. If it is not the order is mentioned, then you can't find it. So as it is maintaining an ascending order or a descending order, on the basis of that order we are forming this. So this is the basic scenario of central tendency. But in order to find the centralized or most centralized value, or which value is better or which value is worse, there are many formulas. Total 11 formulas are there, 11 types are there. We will be discussing one after another. So starting with type 1 today, that is called arithmetic mean. Now statistically, I told you there is a qualitative analysis versus quantitative analysis. So qualitative analysis versus quantitative analysis is one of the most important discussions today. If I tell you 1, 1, 1, 67, 1, and another one is 14, 13, 14, 15, 16. Which one is the better player? So if you just add it, this will give you 60, 71. Here you added 1, 2, 3, 4, 5, 50, 56, 61, 65, 68, 71, 2. Okay. What we are doing, we are just reducing this value to 12. So like 68. So mathematically or in a quantitative analysis, obviously the first player is a better player. Second player is not that good. Although they are close, but the better player is obviously the first because the highest runs. Even if you go for the average, 71 by 4, 14 by 2, 13.6. This is the average. So average also tells you player A is better than player B. But as you can see, the dependability, only one match he has performed well, and here every match he is actually scoring to a basic standard. So we will accept the player B as a player, better player with respect to consistency level. So with respect to consistency, he is better. With respect to average, he is better. So this is called qualitative analysis gives you player B into T, but quantitative analysis takes player A into T. This is the main distinction of a central tendency structure. In a central tendency basic format, we find the mean. The mean is like the class 7-8 format only. So mean is summation of x by n. And as you already know the frequencies, so in case of frequency, it is summation of fx by summation of f. Summation of f means sum of the frequencies. That is very general formula. But what happens if there are two groups? Like group 1, group 2, let's take 3 groups. And their averages is, their mean is, in general mean is expressed by this, x and a bar. So x1 bar is 5, x2 bar is 10, x3 bar is 15, n1 is 5, n2 is 10, n 20 and n3 is 8. So n1, n2, n3 is the number of people in each group. So you have to find the entire group's average. So there is a combined average formula. So that is like capital X bar equal to n1 x1 bar, n2 x2 bar, n3 x3 bar, So remember that the average is why the central, why we are always planning to come to the central value is needed. The central value can only give you the idea of the entire thing, because you are not going to examine. For example, a player have 255 innings, then what happens? Are you going to examine all the matches? What are the runs, scores? No, you just go the average, you check the average. Because what happens, maybe Sachin Tendulkar is a very famous cricketer and he has played like 400 matches and he has a very good average. Okay, but if you take a small cricketer, any small batsman who is not that good, okay, and his average is 17, and a tail ender, his average is 25, maybe 2 matches. He played 2 matches with 13 and 15, and another player who has played 200 matches with the average of 24. So who is a better player? So obviously we will say, is the player with 2 matches is a better one? No. Because the number of matches also makes a very crucial role. So, although the average is high, but also we need to check that who is really better. So, very fallacy based question is, if one match 15 runs and 100 match and 1500 runs, who is a better player? Who is a better player? Are they equally good? The mathematical analysis says yes, they are equally good. But according to this pattern, although their averages are both 15, but this has a consistency till the 100 matches. So if this is called the sample size. So if the average is same, then higher the sample size with the same sample and the same average, he is better. So sample size is an important indicator. Important indicator in a data set. So sample size is an indicator. So obviously you could put the value and get the answer to the question, which will be 25 plus 200 plus 120 divided by 33, 345 by 33. This is your answer. So this will give you 10.3. Clear? So this is the value of average. Remember that if the averages of the group are like 5, 10, 15, it should be very close to 10, and it is happening. So this is called centralization or central tendency. We have the tendency to focus around the central most value of a data set. So now, this is the arithmetic mean. Now, what happens? There is a new term I am going to introduce, that is called, the new term is called origin and scale change. The new terminology is called origin change versus scale change. What is origin change versus scale change? For example, the values are like 150, 160, 170, 180. So if you subtract 160 from each values to make it small, it is called origin change. And if you divide by 10, it is called scale change. So minus 150 from each, subtracting 150 from each is a origin change. Even if the values are like minus 10, minus 15, minus 12, minus 11, in order to make it positive, if adding 15 to each, if adding 15 to each will make it 5, 0, 3 and 4, all values are positive. So adding and subtracting is called origin change. So origin means plus or minus, and scale change means, in order to make the value small, divide or multiply. Divide or multiply, these are the two operators are called origin change or scale change in a grouped data. So now we are proceeding to the next part. Is origin change and scale change affect the value of arithmetic mean? Answer is AM is affected by origin change or scale change directly affect. Okay, so just the way the origin and scale is changed, just the same way it will be done. For example, the values are a mean as y equal to a plus bx. Here the value of y is changed. If the x is the original values and b is multiplied, then a is added. Then a is called the origin change and b is called the scale change. A is called the origin change and b is called the scale change. This is very much needed in order to understand this kind of structure. Next one is called median. Today's next topic, we are proceeding to median. Median is mean middlemost. In a group set of data, you need to find out the most middle data. But in order to do that, you have to notice, arrange them in ascending or descending order. Order doesn't matter here. Any kind of order you can do it, and the middlemost value. If there are two values, you take the average. For example, if the values are like 4, 6, 8, 9, 14, 16, 19, 24, so 4, 6, 8 values. So what are the two middlemost? These are the two. So take the average of these two. So that is 11.5. And if the values are like 4, 6, 8, 9, 14, 16, 19 only, then the middlemost value is this. So this is the median. Remember, the median, again median is also affected in the same way like the mean affected. So mean and median both are affected same way by origin and scale change. For example, if I change all the values by 10, so this becomes like this. So the new value is average of 19 and 24, that is 44, 33.5, sorry 43.5. That is also 21.5. See, if I change all the values by 10, then the median is also changing by 10. If you multiply all the values by 100, the median will also be multiplied by 100. But what happens, this is for discrete case. If the case is continuous, if the data is continuous like 0 to 10, 10 to 20, 20 to 30, 30 to 40, then you just can't apply this because the frequencies with respect to each class they are changing. So in that case, we are going to incorporate a new idea that is for continuous cases. So for that, the formula is L1 plus n by 2 minus summation of f by fm into c. This is the formula we are going to apply in that case. For example, I am going to give you an example on this, like 0 to 10, 10 to 20, 20 to 30, and the values are like 4, 6, 8. So what is the middlemost value you need to calculate? So first, the cumulative frequencies will be needed. So this is n. What is n by 2? That is 9. So 9 is in between these two. So if something is between, then we take, obviously in statistics we know the next value. So this becomes the class interval of median class. So this is called median class. This 6 value is called the frequency of the median class. This is called summation of f, and c is 10 because in each case the difference of the class width is equal and that is 10. If it is of unequal class width, the class width of the median class will be taken into our consideration. So now if we put the value, and what is L1? This is called L1, the lower class limit of the median class. So that is 10 plus n by 2, that is 9, summation of f, that is 4, and that is summation of f, sorry, this is 6, 4, this is 6, and this is 10. This is 50 by 6. So answer is 18.3. So 18.3 is your median. Now you can say that, sir, the data is from 0 to 30. The orientation should be at closer to 15. Why it is closer to 18.3? There is a statistical answer to that as well, because the highest frequency is happening between 20 to 30. Okay, so the concentration of the data is very higher in the lower segment. Okay, so if I change the data only these to 34, you will see the answer which will come again up. So where the concentration of the data, there will be the value of the median in case of discrete or in case of non-discrete or continuous values. So now we are proceeding to the next level, which is called mode. In case of mode, things are relatively same. Here also, mode means highest frequency. What do you mean by highest frequency? Highest frequency is like this. For example, a data 1 1 1 4 5 3 6 2 1 1 1 7. You can see 1 is happening maximum number of times. So here you can ask me whether it is needed to put the data in ascending order or not, and the answer is no, you don't need it. Either you can calculate the data or you don't calculate the data. In any way, if you put it in ascending order or not, anyhow you will get the data which is happening maximum number of times. But what happens if this thing is not applicable? If you have a continuous data, then also you have a formula for continuous data. For continuous data, it is like 0 to 10. Okay, and it is like 4, 6, 8, 16, 4, 2. So this is the highest. This is we are choosing as F, only F. The frequency before is F1 and the frequency following is F2. Then there is a formula of mode which is called L1 F minus F1 2F minus F1 minus F2 into C. So here mode, what is the modal class? This is a modal class, as we already discussed. This is L1 and this is F. So all your job is to put the values. F, that is 16 minus 8, that is 32 minus 8 minus 4 into C, that is 10. So 30, 80, 20, 40, that is 34. So simply 34 is the modal value. Remember that in case of modes, obviously the mode will has to lie between the 30 and 40. This is your answer. So in case of an MCQ, if you see the 4 options and 3 options are not in the range, so without calculating you can get your direct answer. So this is the type of questions you can expect in examination, and there will be an interrelationship between mean, median and mode, and that is 3 into mean minus mode. Sorry, mean minus mode equal to 3 into mean minus median. How to remember where to multiply? That median is relatively have 6 letters. So whatever has the highest number of letters, you multiply the number with that. So median, if you know any 2 of them without any further calculation, you can find the rest of it. Now there are very useful applications of this formula of median. Using the formula of median, we can calculate the quartiles, percentiles, deciles. In most of the cases, they will give you separate formulas, but here we will be doing it with respect to any one particular formula, and that's like this. Q1. Q1 means first quartile. What is the meaning of this quartile? If you are thinking that quartile has to do with quartile, you are right. So quartile means dividing the entire data into 4 equal parts. The quartile means the first part, then the second, third and fourth. So obviously there are 4 possible quartiles. So Q1 has a formula which is the first quartile, that has a formula of L1 plus n by 4 minus summation of f by fm into c. If you see closely, the formula of median was L1 plus n by 2 minus summation of f by fm into c. So by incorporating one formula and just by changing the denominator of n to 4 from 2, you can get a new formula. So what is median? Does it have a presence or any importance with respect to quartile? Yes, it is called the second quartile. What happens if you have the third quartile? If you have the third quartile, so it will happen L1 then 3n by 4 summation of f fm into c, and if you want to have the fourth quartile also, then fm, then it is only n minus f fm into c. You see these two are same. Capital N is same as this, so these two will 0. So Q4 is nothing but L1. This is also a small proof of this kind of structure, that Q4 equal to L1. Okay, Q4